Good evening, everyone. So, let us start today's discussion. Let us share the screen. Okay. So today we will start discussion with Bayes theorem. Okay. So let us start. And in between, if you face any doubt, you can write in the chat box. Okay. Okay. Fine. Let's start. So Bayes theorem. What is Bayes theorem? So Bayes theorem uses total probability theorem. Okay. So let us take some example, or let us discuss the theorem first and we will take some examples. Okay. So is there anyone? No. Okay, fine. If there is a sample space S, what is S? S is sample space. S is a sample space and there are some mutually exclusive events. Bn are mutually exclusive events for n is equal to 1, 2, let's say up to n. Okay. And there is another event A. Okay. Now the thing is, what will be the conditional probability of Bn conditioned on A? This is the question. Okay. So we are discussing the Bayes theorem. S is a sample space, and in this sample space there are multiple events. Let us take capital N number of events, Bn, for n is equal to 1 to n, which means there are events B1, B2 up to B capital N. Fine. So this capital N number of events are mutually exclusive, we are considering, and there is another event A. Okay. So now the question is, what will be the conditional probability Bn upon A for any n? Okay. So let us take this question. It will be, we already know what is conditional probability, so from there we can say this is nothing but the probability of Bn intersection A upon probability of A. This is clear. So now what we can write from the conditional probability, we are getting this. Now we need two expressions. What is the expression of probability of A and probability of Bn intersection A? This probability of Bn intersection A will be probability of A conditioned on Bn into probability of Bn. Okay. And another thing is, what is the probability of A? So last week we have discussed that probability of A we can get from the total probability theorem, which is let's take as, okay fine, n is equal to, n may be little bit confusing for you, so let's I is equal to 1 to capital N probability of A conditioned on Bi into probability of Bi. Up to this it is clear. Up to this, is it clear? Okay, so I am considering that it is clear till now. So from these two expression, we can say probability of Bn upon A is equal to A upon Bn into probability of Bn into this divided by this. And what will be divided by this? If we put I is equal to 1 to n, then we will get probability of A upon B1 into probability of B1 plus probability of A upon B2 into probability of B2 plus probability of A conditioned on B capital N into probability of B capital N. Okay, this is Bayes theorem. This is Bayes theorem. And what it says that, let us assume that there is a sample space S. Over the sample space, there are many events, capital N number of events, which are B1, B2, and up to Bn. There is another event B, another event A. Okay, and the event B1 to Bn are mutually exclusive, but not mutually exclusive with A. Okay, now if we have the probability of Bn for any n, B small n for any n, or better to say, we know that probability of B1, probability of B2, up to probability of Bn, and we know that probability of A upon B1, probability of A upon B2, I mean conditional probability, and probability of A upon Bn. If we know this, then we can easily calculate probability of B small n upon A for any small n from 1 to n. So let us take some example, then you can understand it in a better way. And in between, if there is any queries or confusion, please write in the chat box. Okay, so as of now there is no query, so let us take the example. So you people have received the notes of all the classes? Anyone? Last time in last class someone was asking. I think it is not audible. No, not audible. Can you please write in the chat? You are not audible, so please write in the chat box that whether you have received the previous slides and this OneNote file, basically the notes of the class. And till then, we will take some example. Example 1. Okay. Example 1 is there are two boxes. So let us take two box 1 and box 2. There are two boxes. First box contains two white balls. So this is box 1 and this is box 2. The first box contains two white balls and three red balls. And second box contains three white balls and four red balls. Okay. Now the question is, what is the probability of drawing a white ball? There are two boxes, B1 and B2. First box contains two white, three red. Second box contains three white and four red boxes. Okay. Now we are picking a ball randomly from any of the two boxes. Now the question is, if we are picking a ball randomly from any of the two boxes, what is the probability that the ball we have picked is white? Okay, let us solve this. So from the total probability theorem, we can write that probability of getting the ball to be white is probability of white ball conditioned, that ball is picked from box 1, into probability of B1. That means probability that we are picking a ball from box 1 plus probability of white ball picked from condition that it is picked from box 2 into probability of B2. This is from the total probability theorem. Okay. Is there any query? If there is any query, please write in the chat box.
No, sir, actually, we are not permitted to write in chat box actually.
Not allowed, but
No, sir.
it should not be. Let me check. Okay, I will check it with some setting maybe there. So if there is any query, please ask. Okay.
Okay, okay, sir.
So the previous notes you have received.
Yes, sir, I received.
Okay. So and if there is any query, please ask. So this is the question, and from total probability theorem we are getting this. Now the question is that what is the probability of B1 and B2? There are only two boxes, so probability of B1 will be, we cannot pick ball from any other box, so either from B1 or from B2 we will get. we will fix, so it will be 1 by 2. Okay, and probability of B2 will be same. As we are randomly picking ball from B1, B2, there is no biasness. So it will be 1 by 2 and 1 by 2. Now the question is, what is the probability that a ball picked from block 1 is white? That means probability of W conditioned on B1. So there are total 5 balls and total white ball are 2. So it will be 2 by 5. And probability of W upon B2 will be 3 by 7 in the similar way. So now we can write that probability that the ball picked randomly from any of the two boxes is probability of W conditioned on B1, that is 2 by 5, into probability that box 1 is picked, so 1 by 2, plus probability of W upon B2 means 3 by 7 into same probability of B2 is 1 by 2. So this will be 1 by 5 plus 3 by 14. Okay, whatever the result will be, that will be the probability of picking any ball randomly from two boxes is white. Okay, now let us come to another example. Is it clear till now?
Yes, sir, clear.
Okay, so now example 2 is little bit tricky, so understand it carefully. Example 2, let us draw a figure first. This is input X and output is Y. And let's say this is channel 1, or in a better way you can say this is channel A, this is channel B. Okay, now there are binary communication channels. These are binary communication channels. The channel input symbol is X and it may have two state, either 0 or 1, because it is binary, and similarly output is Y and it may be 0 or 1. But there is some noise in the communication channel. So if input is 0, due to some noise it may become 1, and if input is 1, due to some noise it may become 0. Now so there are two more lines we're trying. This is X, this is Y. X is the input, Y is the output. Input may be 0 or 1, output may be 0 or 1. So ideally, if there is no noise, then if input is 0, output should be 0. If input is 1, output should be 1. But there is some noise, external noise, which disturbs the channel. And due to the noise, sometimes it may happen that even if input is 0, output is becoming 1. Or even if input is 1, output is becoming 0. But it should not be ideally. Okay. Now, the question is, or there is some other data is also given. So let us define it A, B, this is C, this is D. So there are 4 events. Event A means if input is 0, output is also 0. Event B means if input is 1, output is also 1. Event C indicate that if input is 0, output may be 1 or output is 1. And event D indicate that if input is 1, output is 0. So the 4 events are characterized here. Now we assume that A is equal to event A. What it means indicates that, or probability of A, if we write that, it will be probability of y 0 upon x 0. This is for event A. And this is probability for A. What is probability for B? B means we are getting y1 upon x is also 1. This is for event B. Probability of event C is output is 1, condition that input is 0. And what is probability of event D? Output is 0, condition on input is 1. This is for event D. Okay, where x0 denotes that input x is 0, and x1 denotes that input x is 1. Similarly, y0 denote that output y is 0, y1 denote that output y is 1. And it is given that probability of y1 upon x0, y1 upon x0, that means pc is given, it is 0.15. Okay, and Another thing is given probability of y0 upon x1. That means PD. It is also 0.15. Now, first question is find probability of y0 and probability of y1. What is probability of y0 and what is probability of y1? This is first question. Okay. So let us solve this. So in input space, there is two events, either x0 or x1. There is no other event in input. So we can write that probability of x0 is equal to probability of x1 is equal to 0.5. Both have equal probability that either input will be 0 or 1, as there is no biasness. Now we have to calculate probability of P0, y0. So let us write it first. Probability of y0 what will be, using again total probability theorem. It can be in two way, that y0 can happen when input is x0. So probability of y0 upon x0 into probability of x0, or it may happen p of y0 upon x1 into p of x1. What is y0 upon x0? This is a, p of a. So p of a into p of x0 plus what is y0 upon x1? Y0 upon x1 is probability of d, so pd into p of x1. Now the question is, we have probability of c, pc and d. So d it is required here, but we need pa. How to calculate pa? Pa means probability of y0 upon x0. So how to calculate that? Anyone can tell it? Please think 1-2 minutes. How can we calculate? Can anyone tell this? If we know PC and PD, how to calculate PA and PB? Okay. What PC indicates? PC indicates that output is 1 when input is 0. So there, if input is fixed, that input is 0, then there can be only two cases, either output is 1 or 0. So if input is 0, then there can happen only PC, event C or event A. So PA, and we know that total probability is always 1. So it will be 1 minus PC, which is 0.85. Similarly, if PD indicates y0 upon x1. So if input is 1, there can be only two cases, either output will be 0 or 1. So similarly, using PD, we can calculate PB, which is 1 minus PD, which is again 0.85. Is it clear?
Yes,
So
sir,
PA
clear
is
now.
okay. PA is 0.85. If there is any doubt, please ask. Probability of x0 is 0.5 plus PD. PD we have 0.15 into x1. X1 is 0.05. So probability of y0 is nothing but, if we calculate this, we will get 0.5. Okay. Now, what is probability of y1? Probability of y1 is simply, again similarly, probability of y1 upon x0 into probability of x0 plus probability of y1 upon x1 into probability of x1. What is probability of y1 upon x0? Y1 upon x0 is PC into probability of x0 plus what is probability of y1 upon x1? Y1 upon x1 is PB and it is px1. Px1 means this is px1 only. PC we have 0.15 into 0.5 plus PB. PB is 0.85 into 0.5 is equal to again 0.5. So if we want to cross check, then probability of y0 and probability of y1, the sum of these two should be 1, and it is coming because at output there is no alternate option, either it will be 0 or 1. So the probability of getting 0 or getting 1 should be 1 only, right? Now come to the next question. Not next question, question is same, part 2 of this question. Now it is observed that at output 0 is occurring. if we say that output y0 is fixed, okay, out at output we are getting y0, this is fixed. Now what is the probability that at input was x0? If this is fixed, so what is the probability that x0 is happening? This is our question, that we are saying that output we are getting 0. Then what is the probability that from input side 0 was sent? So this is nothing but the probability of x0 conditioned on y0, right? And we have already discussed that these are our values. So we have probability of y0 upon x0, but we have to calculate probability of x0 upon y0. How to calculate? Now we need to take the help of Bayes theorem. What Bayes theorem says? Using Bayes theorem, we can say that this is probability of y0 upon x0 into probability of x0 and divided by the whole probability or total probability of y0. Let us look into the Bayes theorem. This was the Bayes theorem, right? This is nothing but the probability of A only. So using that, we can write this. Is it clear till now?
Yes, sir, clear.
Okay. If there is any doubt or any confusion, please ask. And we know probability of y0 upon x0 is given PA we have calculated 0.85 into probability of x0 is this 0.5, probability of y0 we have calculated 0.5, so it is 0.85. Now we will go to the next question or next part of this question. We are saying that it is observed that at output we are getting 1. This is fixed. So we need to calculate that what is the probability that input was 1 or input 1 x1. This is the question. Basically we have to calculate that what is the probability that input was 1 x1 condition that output was 1. So can you calculate or can you try to calculate the value? Take 2-3 minutes and try to calculate. If it is done, please tell the answer. Otherwise, I will solve it.
0.15.
0.15. Let us solve this. That what is the answer? Probability of x1 upon y1. It means it will be probability of y1 upon x1 into probability of x1 divided by the total probability of y1. So what is probability of y1 upon x1? y1 upon x1, that means p of b, probability b, and pb is 0.85 into p of x1 is 0.5, p of y1 is 0.5. No, it is coming 0.85. I think you have made some mistake in putting the values. Please check it. Okay. Now there is another part of this question, that question is, what is the probability of error? It is very important question and interesting question. What is the probability of error? Let us say P is the error. So what is error? We need to know first, right? Error means if input is, or rather output is 1 when input is 0, it may be error. And what can be other thing, that output is 0 when input is 1. So basically we have told that if input is 0, output should be 0. If input is 1, output should be 1. But there are two more events, and those two events are considered as error. So let us try to calculate probability of error. Probability of error will be probability of y1 upon x0. And when this will happen, we are saying that y1 upon x0 multiplied with probability of x0, we are saying that x0 is happening, and if y1 is happening, similarly probability of y0 upon x1 into probability of x1. So what is probability of y1 upon x0? y1 upon x0 means pc. Pc is 0.15. Into p of x0 is 0.5. I think it was 0.15. Okay. plus P of y0 upon x1. What is y0 upon x1? It is PD. PD is 0.15 again. Into P of x1 is 0.5. So it will be ultimately 0.15. This is the probability of error. Now, these are the examples using Bayes theorem. Now, we will learn few concepts and then again we will solve some problem. One important thing is independent events. Independent events. What are independent events? If there are two events, let us consider there is a sample space S and in that sample space two events are there. Two events are in S is the sample space, okay? And having non-zero probabilities, this probability of A and probability of B are not zero. And if occurring of any event, so let us write first probability of A not is equal to 0, probability of B not is equal to 0. This is first condition. What is the second condition? That occurrence of any event is not affected by the occurrence of other event. Then we can say that A and B are independent events. Okay, so first condition is the probability of this any of the event is not zero. Second is occurrence of any event is independent from occurrence of other event. Now if A and B are two independent events, then there are some properties. What are those? Let's write. Then probability of A intersection B will be probability of A into probability of B. Okay. Again, for P of A and P of B not is equal to 0. Now the question is that what will be the conditional probability for independent events? So let us write. What will be P of A condition P of B? Can anyone tell this? What will be the answer?
The
Try to
probability
think.
A.
Yes, probability A. How it is coming? It is nothing but the probability of A intersection B divided by probability B, and probability of A intersection B is probability of A into probability of B, so it will be probability of A. So now can we realize this intuitively without using the mathematics? Okay, let us try to understand this intuitively. This is the whole sample space S. We are saying that two events are independent. So let us write this is event A, this is event B. Okay. Now we are saying what is the probability, that probability A conditioned upon probability B, or probability A conditioned B. If we are saying that probability of A is independent from probability of B, whatever the probability of B can be, it can be 0.1, it can be 0.9, whatever. Probability B is completely independent from event B, or event A is completely independent from event B. So if it is not depending upon B, then the probability of A condition B will be probability of A only. Intuitively we can think like this. Similarly, what will be probability of B conditioned on A? It will be probability of B only, right? Now if there are three events A, B and C, so A, B and C, there are three events, and we are saying that these are independent from each other. Then what conditions we will get? If these are independent, let us write ID. ID indicates independent. Okay, so we will get probability of A intersection B intersection C will be nothing but probability of A intersection probability of B intersection probability of C. This one. Okay. So now let us proceed. Let us take some examples. Example 3. it is given that probability of A is 0.8. Okay, probability of B is 0.6. Probability of A intersection B is 0.5. Okay, now first question, what is probability of A union B? This is a general question of probability. So can we realize this using the diagram? Let this is the whole sample space S. This is probably this is event A and this is event B. So this part indicates the A intersection B, right? So using A probability of A union B, if we try to calculate, it will be probability of A plus probability of B minus probability of A intersection B. What is the value? It is 0.8 plus probability of B is 0.6 minus A intersection B is 0.5. So it is 0.9, right? Now question 2 is, listen carefully, or are A and B independent events? Can you answer this? This is the whole question, and the question is, are A and B independent events? Please take
No, sir.
2-3 minutes. No, correct. Why not? Because
Sir, because they have a intersection part.
yes, correct. And if we try to prove it mathematically, we can say for independent events, we have seen that A intersection B will be probability of A into probability of B. So it should be 0.6 into 0.8, which is, but it is given that it is 0.5 only, which is not equal to 0.8 into 0.6. So mathematically we can prove this, right? Now question number 3, or part 3 of this question. What is a probability of A intersection B transpose, or B complement, whatever you say? Can you calculate this? Take 2-3 minutes and think, how can we get this? Take 2-3 minutes and think. This is the question, that probability of A is 0.8, probability of B is 0.6, probability of A intersection B is given 0.5. So what will be the probability of A intersection B transpose? Think about this, take 2-3 minutes. Okay, so let us try to solve
Sir, is
this.
it 1 minus 0.5?
Yes,
Is it 1 minus 0.5?
you are saying 1 minus 0.5. Let us solve this, then we will check whether it is coming this or not. From this Venn diagram, can you say that probability of, let us first realize that what probability of A intersection B complement is. A intersection B means this area. Now what is B complement? B complement means all the areas except this probability of B, or event B, this, right? Now if we say that A intersection B complement, B complement means this whole area, and A means this area, right? So if B, A intersection B complement, if we say, then we will get this area only. Okay, so can we write this probability of A minus probability of A intersection B? Probability of A minus probability of A intersection B, right? So probability of A is given 0.8, minus A intersection B is 0.5. So no, it is not 1 minus 0.5. I think you have taken 1 minus 0.5. If we say that, then it will be the 0.5 is this area, so whole minus this area, right? It is good, very good that you are trying, and you have to solve the question like this only, right? Even if you get the wrong answer, uh, it doesn't indicate anything, but indicate that if you are not trying. Actually, basically, getting the right answer and getting the wrong answer, there is no difference. The thing is, you are trying. So very good. So it is 0.3. Okay. Now we will come to next part of this question. It is what will be the probability of A complement intersection B complement. Now please try to think. Take 2-3 minutes and think what is probability of A complement intersection B complement. Try to solve. Take 2-3 minutes and think that, first think that what A complement intersection B complement indicates. If this is event A and this is event B, take your notebook and try to draw this figure and identify that what A complement intersection B complement indicates. And then only you can think that what can be probability of A complement intersection B complement.
Sir, now the answer is 0.5.
0.5, I don't know, I have to check, right? Let us check. If A complement intersection B complement, let us draw it again. Okay, this is whole sample space, this is A, and this is B. Okay, now let's take some other color, red. Now if we say that what area is A complement, this whole area, if we put other than A, right? Even this part of B also is under A complement. Okay, now Let us take another color. Let's take blue. And if we are saying B complement means this whole area. Let's use blue dash for the whole B complement. Okay. Now think that which area indicates A complement intersection B complement. Means the common area of dotted blue and dashed dotted red and dashed blue, right? So it is this area. So how to get this area? We can get this, the whole area S minus A union B. So we can write 1 minus probability of A union B. And what is A union B? A union B we have calculated 0.9. So it will be 1 minus 0.9, which is 0.1. You understand this?
Yes, sir.
Okay. No doubt, or there is any doubt?
No, sir, understand.
Okay. Then we will go to the next question. Okay. Example 4. Try to solve as much as problem you are getting from any book, whatever book you will get in your library of your college, or wherever you are getting any book of probability. Take any book and solve as much as problem you can. Okay. So let us take another example. So we are considering an experiment. Okay. An experiment which consists the sum of the outcome when two fair dice are thrown. Die means, you know, die, there will be 6 outcomes from 1 to 6. Okay. And two dice are fair. So two fair dice are thrown okay. Now, and we are observing the sum of the outcome. So we are what we are observing, the sum of the outcomes. Okay. Now, question is, or question 1 is, what is the probability that sum, let us S indicate sum, okay, sum is 7. This is the first question. So let us solve this. There may be total 36 possible outcomes of the experiment. And now, what are our expected outcomes? If sum is 7, it may be 1, 6, it may be 2, 5, it may be 3, 4, and 4, 3. It may be 5, 2. It may be 6, 1, right? So what is the probability that sum is 7? Total expected outcome is 6, and total outcome can be 36. It is 1/6 only. Okay. Now the second part of this question. What is the probability that sum is greater than 10? Can you solve this? Please take 2-3 minutes and try to solve.
Sir, 3/36.
3/36.
36.
Let me check. What is greater than 10 means it can be 6, 6. It can be 6, 5, and it can be 5, 6. So there are 3 expected events. So probability of sum is greater than 10 is 3/36. Right? Good. Now let us take another example. Example 5. A very interesting problem we'll solve. That it is given that probability of A conditioned on B is greater than probability of B conditioned on A, then it is given. Okay, then we have to prove what we have to prove, that probability of A is greater than probability of B. So let us try to solve this question. What is probability of A conditioned B? It is probability of A intersection B divided by probability of B, right? And probability of B under the condition of A is again probability of A intersection B divided by probability of A. Now it is given that probability of A condition B is greater than probability of B conditioned A. That means probability of A intersection B divided by probability of B is greater than probability of A intersection B divided by probability of A. So we can write 1 upon probability of B is greater than 1 upon probability of A, or from this we can write probability of B is less than probability of A, or in reverse form if we write, it is probability of A is greater than probability of B. And it was to be proved, right? You understand this? Any doubt?
Yes, sir, understand.
Okay. So now we will go to the next question. It is example 6 now. Okay. A and B are two events. A and B are two events, and S is the sample space. Okay, these are events, and this is sample space. Now, question 1 is, what is probability of S with condition B? This is first question. Can you solve this? Try to solve and then we will check the answer.
Sir, 1.
1. Very good. How we will get this? It is probability of S intersection B divided by probability of B, and S intersection B is nothing but probability B only. Then it is probability B, which is equal to 1. Okay. Now this is very interesting question. Now we are dividing the event A also. Okay. There are two events A1 and A2. Okay. And B is separate event, whatever. So these are events. Event A1 and event A2. Okay. And there is a condition given that A1, look very carefully, intersection A2 is 5. 5 means null set, or no element is there. So can we say that A1 and A2 are mutually exclusive? Can we say this?
Yes, sir.
Okay. Now we have to prove one thing. Look very carefully, this is very interesting. Prove that probability of A1 union A2 under the condition of B is equal to probability of A1 condition B plus probability of A2 condition B. It is to be proved. So now let us try to solve this. We can write A1 union A2 conditional B. Can we write this like this? A1 union A2 intersection B divided by probability B. This is nothing but the formula from conditional probability. Right? Now what we can do? So let us calculate this first. Probability of A1 union A2 intersection B can we write it like that? Okay, so before it, let us do some rough work. A1 union A2 intersection B. What is this? This is A1 intersection B union A2 intersection B. Can you write this? If there is any confusion or query, please ask. This we are writing, so can we write this? Hmm?
Yes, sir.
Okay, it is clear?
Yes, sir. Clear.
Okay. Now, if we say that probability of, okay, here we will come later. We are saying that A1 intersection A2 is phi. Okay. So this is also phi. If we are intersecting B with a null matrix, then what we will get? Another null matrix or null set. Is it understandable? Look at this once. If there is any confusion, must ask.
Sir, I can't understand this part.
Okay, very good that you have asked. let us think that this is let a C, event C, then and this is event D. And if we say that C intersection D, if we say this, then which area we will get? Nothing but this area, right? Now come to next thing. This is a sample space and there is a event, let us say E, and there is another event F. Okay, and F is a phi only. Now what will we say? That if we intersect E and F, where F has no area in the sample space, F is empty, then what uh, which area we will get E intersection F? Think.
And
C
null.
is this, exactly, null. If C was this, D was this, then the common area. If E is this and F is null, then and we intersect this, then we will get null. This is here also. A1 in union and here. Now come to this, okay? This is only here used. A1 intersection A2 is 5. Now take a set is the sample space, okay? A1 and A2 has no common area. This is A1, this is A2, there is no common area. Now there is another event which is B. Now look, A1 intersection B. A1 intersection B is this area, and A2 intersection B is this area, right? Now if we say that this area intersection this area, right? A1 intersection B means this area. Okay, this is B, and intersection A2 intersection B, then it is nothing phi, and here it is writing, okay, it is union, no, it is intersection. sorry, this is another thing we are writing. Let us take a box here. Okay, these are some rough purpose, not this. I was hoping it was intersection, but no, it was union. So A1, this is phi. If A1 intersection A2 is phi. You understand?
Yes, sir.
Okay. From this we are getting this. Now we will come to another point. Ultimately our goal is to prove this, right? So now come to this probability of, question was A1 union A2 conditional B and so can we write this, whatever we were writing, let us write it first. A1 what was union A2 intersection B divided by P of B. Now A1 union A2 intersection B is this. So let us write it. Probability of A1 intersection B union A2 intersection B by probability of B. Now can we write this like this? A1 intersection B plus probability of A2 intersection B minus of probability of A1 intersection B intersection A2 intersection B divided by probability of B. Now look at this. If A1 intersection B intersection A2 intersection B is phi, then its probability will be 0. So we can write like this: probability of A1 intersection B plus probability of A2 intersection B divided by probability of B, right? And if we break this, then we will get probability of A1 intersection B divided by probability of B plus probability of A2 intersection B divided by probability of B. And what is this? This is nothing but probability A1 under the condition of B plus probability of A2 under the condition B. And it was only to be proven, right? This one. So is it clear or there is any confusion?
Sir, A1 and A2 are mutually exclusive. So can we
Yes.
write directly that probability of A1 intersection B union probability A2 intersection B is equals to probability A1 intersection B plus probability A2 intersection B. Can we
Yes,
write this
yes.
directly?
Yes, definitely we can write this directly. It is this only, that probability of A1 intersection B union probability of A2 intersection B is probability of A1 intersection B plus probability of A2 intersection B. And we can realize this also using diagram, right? That if it is A1, if it is A2, and if there is another event B. So if we are saying that what probability of A1 intersection B means this area, A2 intersection B means this area. So we can directly say from this diagram that probability of A1 intersection B union probability of A2 intersection B will be A1 intersection B plus A2 intersection B, because these are separate areas, right? Very good observation you have made. Any doubt?
No, sir. Clear, all clear.
Okay, very good. So now we will solve one more question. We have very limited time, so let us take a question. It was example 6, right? Very simple question. Example 7. Let us take a diagram. It is S. Okay. There is an event. Very simple question for understanding purpose only. This is B, or rather this is B. Okay. Now it is given that probability of A is 0.1. Okay. Probability of B is 0.5. Is it possible that probability of A intersection B is 0.2? Is it possible? Very basic question. Take 1 minute or 30 seconds and think. It is given that this is a sample space, this is A, this is B, and this portion is A intersection B, right? Probability of A intersection probability of B. So we are saying probability of A is 0.1, probability of B is 0.5. Is it possible that probability of A intersection B is 0.2? Intuitively you think. No, it is not possible. Why? Look, I'm saying that any event is happening in this sample space, and the probability that it is happening in A, this much area is A, is 0.1 only. So, and now if we say that probability of A intersection B is this area, or rather mark it whole as red. I am saying that the probability that any element we are choosing from this whole entire area, this A is 0.1, and now I am saying that probability that any element we are choosing from this much area, which is less than this entire area, is 0.2. So is it practically possible that we are choosing an element from the whole area is 0.1, but a small part of that area is 0.2? It is not possible, right? You understand?
Yes, sir.
Okay, so it is not possible. Okay, so let us end the discussion here. Okay, we will start discussion from next week on random variables. Okay.
Thank you, sir.
Okay, I will share this in the same link. Okay.